Okay, so this video we're looking at Venn diagrams at the grade 6 level and an introduction to set theory notation, which we'll get onto now. So what is set theory notation? Okay, so we'll look at a few questions in a second that kind of go through this, but we need to really understand this stuff here first. So we've got here, and let's get a highlighter ready. Okay, so what I would do is I'd make a note of these 6 diagrams that we go through, because this kind of covers you for what you need. So here we've got this just means the set. So we've got a Venn diagram here where we've got 2 options. They could be anything. It could be brown hair, it could be blonde hair, right? But I've just called it A and B, okay? And we're saying, right, if you were just asked for everything in set A, that would be asking for literally everything within this circle, and that is here. So everything within A, okay? That is what is meant by A. We're looking at everything within that set. So similarly, it follows on with B, that we're looking at everything within set B. So we're looking at this part of your Venn diagram. Okay, and you'll see what this really means in a second with regards to probability, okay, because it will say the probability, for example, of getting everything within this set B. Okay, maybe some new terminology then here. We've got this A dash, which means the complement of A, right? And this one means everything except A. So you do not include A at all. So we have to go everything except A. So it's going to be everything, right, that is literally not A. So complement means not A. So everything here. Okay, sorry, that's not particularly well shaded in, but hopefully you can see, right, we're literally looking at everything over here. So all of this stuff here, everything here. Okay, but nothing, right, inside A. Leave it blank. So similarly for this one, B dash, the complement of B, we're looking at everything that is not B. So we're looking at everything outside of B. So everything outside here. Okay, and it's not particularly easy to shade on this, but it's hopefully you get the idea. So we're looking at everything that literally is not B, the complement of B. So make a note of these as we go through. Next one, this will be some new notation probably and terminology for a lot of us, unless I've taught you this before. We've got A and this little symbol here, which represents a union. Okay, and A, often we just call it A, U, B. It's not really a U, but it looks like a U. But A union B is looking at everything within the circular parts of the Venn diagram. So everything in this part of the Venn diagram. Okay, that is what is meant by A union B. So including the middle part and then both A and B individually. Okay, and then last but not least, we've got this new bit of terminology as well. We've got A intersection or intersect B, okay, which we say A, oh no, we just say A intersect B really, and that is just referring to the part where both your diagrams intersect. So this part here, okay, just the part that are both A and B. So make a note of those, and then we can begin to look at a couple of examples. So let's go through the first one, and you can try one yourself after this one. So we've got this just here. This just means in the set. So we're saying we're looking at odd numbers that are less than 20. Okay, and we're going to go and put some numbers in this Venn diagram in a second. But first of all, right, let's just make a note of what these numbers are. So odd numbers less than 20 is going to be 1, 3, 5, 7, 9, 11, all the way up to 19. Okay, because any bigger, it's going to be 21, which is not less than 20. So that is good. Okay, and we're saying, right, we've got in set A, so everything, right, within this part of the Venn diagram here, set A, we've got the odd numbers, 3, 7, 9, 13, and 15. Okay, and then also set B, we've got the numbers 3, 11, and 15. So I've got to go and put in all of my numbers into my Venn diagram. Right, let's do this. Let's begin by looking at, well, which numbers are in both sets A and B? Well, we can see I've got a 3 in A, and I've got a 3 in B. So that's going to cross that one off our list, and let's put it into both, okay, because that 3 is in both. And we've also got anything else. We've also got a 15 and a 15 that are in both. Let's cross that off, and let's go and put that in to both. And then that is it. And then for A, we've just got 7, 9, and 13. So we've got 7, 9, and 13. Let's cross those off, 7, 9, and 13. That all belong to A, so 7, 9, and 13. And for B, we've just got an 11 that is left over. So 1, 11. Okay, and what numbers are left over? Well, we've got a 1, a 5, a 17, and 19. So we've got 1, a 5, a 17, and 19 that do not belong to either set A or B. And hopefully that's all of our numbers. There should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. Good. So I've put in all of my numbers into my Venn diagram. And the question is saying, right, a number is chosen at random, find the probability it is in the set. The first one, A, U, B. So that first one, right, we're looking at everything, right, that is within this set here, okay, for the first one. Well, probability is how many things you'll not, well, let's write it down, right, probability is equal to the number, NO, of successes over your total number of whatever it is. Okay, so your total number of, in this case, just numbers. So AUB, we're looking at, we've got 1, 2, 3, 4, 5, 6. We've got 6 of the thing that we're looking for within this part of our Venn diagram. Out of the total, well, there are 10 numbers less than 20 that are odd. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 6 over 10 is our first answer. If you want to, you could simplify it, divide it through by 2, and say we've got 3 over 5. Okay, either of those are absolutely correct. They're both good. So that is the first answer there, which is good. Either of those is good. Okay, let's go to this now. Part B. We're now looking at the probability that the number is in set A intersects B. So we're just looking right at this part of the Venn diagram here. And let's go and write this one over here so we get some more room. And that's going to be equal to, sorry, we're going from what's got some more room. Well, we've got two numbers, 1, 2. We've got 2 out of, again, a total. There's 10 numbers in total, so 2 over 10, which is equal to 1/5. Either of those, again, is absolutely good to go. So 2/10 or 1/5. Okay, and then last but not least, right, we're looking at the complement of B. So that is saying we're looking at literally everything that is not B. So we cannot include, right, we can't include this 15, 3, or 11 because they belong to B. This means everything that is not B, which is this 9, 13, 7, 1, 5, 17, and 19, which is 1, 2, 3, 4, 5, 6, 7 numbers. So this one, we've got 7 numbers. So it's 7 out of a total of 10. And this one we can't simplify. 7 is a prime number. It will not simplify any further. So that is your answer. Okay, so it's just really being familiar with this set theory notation. Okay, so what you can do now is you can pause the video and give that one there a go if you want to. And then you can fast forward to the end to see the answers with me. So this time, right, we're looking at numbers in the set, prime numbers that are less than 30. So definitely, right, a good idea here to write down all of your prime numbers less than 30. And this is a good kind of reminder of what our prime numbers actually are. And we begin with 2. Remember, 2 is prime. It's only got 2 factors, 1 in itself. Then got 3, 5, 7, 11, 13, 17, 19, 23, 29. Let's just double check that. 11, 13, 17, 19, yeah, good, 23, 29, good. Okay, so these are all of our prime numbers that are less than 30. So we don't include 31, that's above 30. And then we've got set A has got these numbers here, set B has got these numbers here. Let's begin by going through which are in both lists. We can say I've got a 7 and a 7 in both. Let's go and cross that off, and that belongs in the intersects part of our Venn diagram. We've also got a 13 and a 13. Let's cross that one off. That can go into there also. Okay, and then we've got a 2 and a 29. So 2 and 29, that belongs to set A. So 2, 29. And then set B, we've got 11 and 17. So 11 and 17 belongs to set B. Let's just be really careful that we don't miss any of them out. We've got a 3 and a 5 that belong to neither. So in the outside part of a Venn diagram. And then we've got a 19 and a 23 that also belong to neither. And we should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. So then a number shows at random again. Find a probability that it is in the set. So the first one, A union B. Again, oh, that's not what I want. We're looking at everything, right, which is in both parts of the Venn diagram. So how many numbers are in those parts there? Well, we've got 1, 2, 3, 4, 5, 6. So it's going to be equal to, again, 6 over 10. You've got 10 numbers in total, which again, if we divide through by 2, that's equal to 3 over 5. Part A is done. Part B, we're looking at A intersect B. So again, we're looking at this part here. It's the same probability again, which is just the way it happens to be, but it's going to be 2 out of 10. Okay, there's 2 numbers in that intersect part, so 2 over 10 which again is equal to 1 over 5. Good. Good, so either of those, it doesn't matter. With probability, you can leave your answer unsimplified. That is absolutely fine. Okay, and then the third part C, looking at the complement of A, so everything that is not in A, so we cannot include the 2, 29, 7 or 13 because they all belong within A, so not those four. So it's going to be 11, 17, 23, 19, 5 and 3, which is 6 numbers. So this one's going to be 6 over your total of 10 numbers, which is equal to 3/5 again. Either of those numbers there is absolutely correct and good to use. Okay, hopefully that was useful. That was Venn diagrams set theory notation. Next video we'll be looking at Venn diagrams again, but Venn diagrams in a more problem solving kind of questions. Okay, thank you.